Hello and welcome to Python tutorial number 70. Let's pick up where we left off last week and continue our journey in the discovery of data management techniques using the Pandas library. Today we will start off as usual by importing our file. And as you can see on the right hand side, we have a new column containing the purchase date of each car. But wait a second, one of the dates is in the incorrect format. Well, no need to worry, as the Pandas library has us covered. To change the format of the data and make it more easily understandable, we can write df of purchase is equal to pd.to_datetime of, again, df of purchase. In other words, here we are reassigning to the purchase column a new Pandas series which contains the values of the old purchase column reformatted as dates. We can also see when we run our code that the empty value in the purchase column has also been reformatted and now says NAT, which stands for no assigned time, instead of the more conventional NAN, which stands for a generic no assigned number. Now then, if we return to our first tutorial on Pandas data management, which you can also find linked above, we can expand on the concept of deleting empty values by restricting the selection to only one column. What do I mean? Well, let's write, for example, df.drop_na of, for example, subset equals, let's say, purchase, comma, in place equals true. And if we run our code, we can see on the right hand side that only one line has been deleted, namely the one for which the value in the purchase column was empty. The other lines, including those containing empty values in other columns, have instead been maintained. This technique can be very handy when you only want to clear any empty values from a single column instead of from the entire data frame. Finally, what if one or more of the values in our data frame were wrong? I don't necessarily mean empty or in the wrong format as we've seen so far. I mean, for example, what if we knew that a fuel consumption of 12 were unrealistically low and in general could not be lower than 20? Well, we could perform one of four main actions. Replace the value with a more meaningful one, delete the line with the incorrect value, or do either of those actions on the entire data frame by iterating through each line in turn. So in the first case, all we have to write is df.lock 1, fuel consumption equals 20, for example. And if we run our code, we can see that in the second line, the fuel consumption value has been substituted with the number 20. In the second case, we'd write df.drop of 1, in place equals true. And if we run the code, we can see that the line containing the incorrect value has indeed been deleted. Finally, we can apply both of these methods over the entire data frame using iteration. I'll show you quickly how this can be achieved using the deletion method, but it's the same also for the case where we substitute the value instead. We can write, for example, for x in df.index, and then if df.lock x, fuel consumption is smaller than 20, then df.drop x, in place equals true. and that will give us the result we need, as you can see in the example on the right-hand side. With that, I hope you enjoyed today's video, and should you have any questions, then make sure to leave them in the comment section below. As always, thank you all for watching, and I look forward to seeing you again next week. Until then, don't forget to like, share and subscribe. And as always, happy coding!